Hello, thank you. My first video on hydrogen spectrum and the series involved in the spectrum, I noticed the formulas were not clearly shown, but now I'm giving you the formulas that is meant to be used in each of the series of hydrogen spectrum. Now I'll start with the general formula. Listen, watch here. The line spectrum of hydrogen atom is given by the equation. The line spectrum of hydrogen atom is given by the equation. Now this is a wave number equal to 1 over wavelength. This is the wave number equal to 1 over wavelength equal to RB. This RB simply means the Rydberg constant, which is equal to 1.097 times 10 raised to power 6 meter per. Now with this general equation, you have the wave number which equals to 1 over wavelength. This is your wavelength. This wavelength equal to RB. This is your RB, which is Rydberg's constant, which is 9.097 times 10 raised to power 6 meter. Then you open a bracket, 1 over capital N square. That N capital there is a whole number of 1, 2, 3, 4. It can be any other number, infinity, depending on what number you are using or meant to be used, minus 1 over N raised to power 2, then 2. Now that N simply means any integer greater than N, the capital N. Any integer greater than N. Now going straight to the Lyman series, you are dealing with the Lyman series. You have to use this formula, the wave number, which equal to 1 over wavelength, which equal to your RB, open brackets, 1 over 1 raised to power 2. The 1 here, why are you using 1? 1 is because you are dealing with the first series, which is N equal to 1, minus 1 over N 2 raised to power 2 will give you R, open a bracket, 1, because 1 square here is 1. 1 divided by 1 will give you 1. Then minus 1 over N2 square. So depending on the N2 you are using, either you might be using N2 equal to 2 or N2 equal to 3 or N2 equal to 4 and N2 equal to 5 depending. Now go to the next series dealing with the spectrum of hydrogen. You have the Balmer series. You are expected to use this formula for the Balmer series. The wave number equal to 1 over wavelength, which equal to RB, open a bracket, 1 over 2 square. The 2 is because you are dealing with the second series. So in the place of Lyman series, you are dealing with you used 1, but in the place of Balmer series, the N here will be 2. You are dealing with the second series of dealing with the spectrum of hydrogen. So minus 1 over N2 raised to power 2, close the bracket. Then your N1 is meant to be 2. Then your N2 can be 2, then 4. N2 can be 3. N2 can be 3, can be 4. 5, 6, 7, 8, and so on and so forth. So that is dealing with Balmer series. Then followed by the next series, the Paschen series. The Paschen series, your wave number is equal to 1 over wavelength equal to RB, which is the Rydberg constant. Open a bracket, 1 over 3 raised to power 2. Now if you notice in the Balmer series is 2 raised to power 2. In the Lyman series is 1, but dealing with the Paschen series, you are dealing with 3 raised to power 2 minus 1 over N minus 1 over N2 raised to power 2. Close the bracket. So your N1 must be 3, then your N2 starts from 4, because we said the N, the small n is any integer. We said the small n is any integer greater than your capital N. So since your capital N in the Paschen series here is 3, so that means the other N2 will be greater than 3, which is starting with 4, starting with 5, starting with 6, starting with 7, and starting with 8. So now going to the next series here, we have the bracket, the bracket series. You have a wave number equal to 1 over wavelength equal to RB, which is a Rydberg constant. Open a bracket, 1 over 4 square. So now in the place of Paschen series is 3, in the place of bracket series is 4 square minus 1 over N2 raised to power 2, close bracket. So your N1 in the bracket series is 4. So since the N1 in the bracket series is 4, starting with the N2, it will now be, because we said the N must be is any integer greater than any integer greater. Your N is any integer greater than the capital N. So since the N here is 4, your N2 will start from 5, start with 6, start with 7, continue with 8, 9, and so forth. Now the next and the last series I'll be explaining here now is the is the P-form series. In the P-form series, you have the wave number, which equal to 1 over wavelength, which equal to R be the Rydberg constant, open a bracket, 1 over 5. So you notice here is 5, because if you are dealing with the bracket series, which is the 4th series, is 4. So since you are dealing with the 5th series here, the n here will be 5. Minus 1 over n2 raised to the power 2 close bracket. Now since the n1 here is 5, mean the n2 will be from 6, because say the n is any integer greater than the capital N. So since the capital N here is 5, so the n will start from 6, continue to 7, continue to 8, continue to 9, and so forth. So with this, I believe you have gotten the equations that are meant to determine the Lyman series, and this is the general equation. This general equation, which is the wavelength equal to 1 over, wave number equal to 1 over wavelength, which equal to RB, open bracket, 1 over n raised to the power 2, capital N raised to the power 2 minus 1 over n2 squared. So this is general one. Letting you know again, repeating it again, the RB you see here is called the what? The Rydberg constant, which is equal to 1.097 times 10 to the power 6 meter. Then the V bar you see here, the V and a line on top bar, V bar you see here, is called wave number, and it's measured in centimeter or meter. Then the wavelength, the lambda sign here is wavelength, measured in centimeter or meter. Then your capital N can be 1, can be 2, 3, 4, depending on the level you're dealing with. Then your small n is any integer that is greater than capital N. Thank you for watching. One more time, go through the formulas. Lyman series. Can you see it? Lyman series. Then Lyman series. Just follow the pen, go through the formulas one more time. Lyman series. Then path change series. Look at the formula one more time. Wave number equal to 1 over wavelength equal to RB, open a bracket, 1 over 3 square minus 1 over n 2 raised by 2, depending on your n2 you are using, and n2 start from 4, 5, 6, 7, 8, and so on. Then the bracket series, you can see the formula. Wave number equal to 1 over wavelength equals to RB, open a bracket, 1 over 4 square minus 1 over n2 raised by 2, close it. Your n1 is 4. Then n2, since n1 is 4, n2 will start from 5, 6, 7, so on and so forth. Then the last one on the list, the P-form series, which is the wave number here, equal to what? 1 over wavelength, which equal to RB, open a bracket, 1 over the capital N is 5 square. So since this is 5, the n2, depending on the one you're doing, whether 6, 7, 8, or 9. So minus 1 over n2 square, close the bracket. Thank you for watching. God bless you.